It looks like we're live. Awesome. Uh, hello, Alex. Hello, everyone. Thank you, everyone, for joining. I'm Ariel Pérez. I'm the field CTO at Tinybird, and welcome to today's webinar. We're very excited. We're going to be talking about how to enhance DynamoDB for flexible querying and real-time analytics. And with us to help us really on this topic, an expert on DynamoDB. We're excited to have him here talking with us. We've got Alex DeBrie. Alex, can you please introduce yourself? Where are you coming from? And why are we speaking to you specifically about DynamoDB?
Yeah, sure, Ariel. Thanks for having me on. I'm Alex. I'm from Omaha, Nebraska, and 5 or 6 years ago, I kind of fell into DynamoDB for one reason or another, and just sort of went down that rabbit hole and got some expertise in it. So I do for the last 5 years, I've been doing independent consulting focused on DynamoDB. I speak at reInvent on Dynamo, and just work with companies, on building, designing, and maintaining their DynamoDB data models.
Awesome. Well, it's a pleasure to have you here. Did you say where you're based right now, you said?
I'm in Omaha, Nebraska, so center of the U.S.
Yeah,
Most people probably aren't here, but if you'll be at reInvent in 2 weeks, feel free to hit me up and we can chat there.
Awesome. That's why I wanted to highlight that, right? Because people are coming from all over the world, so they might not assume where Omaha, Nebraska is in the U.S. I myself, I have an American accent. I am American, but I'm currently based in Madrid now. So with the Tinybird team, I came over to Madrid. So I'm in Madrid in Spain. Great to see all these folks from all over the world. With that, I think, we're going to dive right in and try to really understand a lot about DynamoDB, all the things it can do and the things that it can't do that well, and then how we fill in those gaps. So hopefully it's going to be an interesting conversation for you all. Any questions that you come up with, anything that comes to mind, please feel free to throw them in the chat. We've got April in there, who's our amazing DevRel. She'll be looking at your questions, trying to make sure and keep the community engaged, and then try to pick out some questions that you have. And Cameron as well, who's our head of marketing, he'll be reviewing as well. So hopefully we'll be able to pick some of those questions and answer them at the end. With that said, getting started, I think, the first question I wanted to ask you, Alex, and get your view on is, what are the key use cases for DynamoDB? What do we use DynamoDB for? And why is it that we use it for that? What is it about it, the architecture, the technology, everything under the hood, don't leave anything out, that makes DynamoDB so well suited to these particular use cases?
Yeah, sure. So I like to say Dynamo is good at like classic OLTP like stuff. So really like the core of your application, any of your basic CRUD type stuff where you're creating a new user or updating an order or deleting a post or just reading records. I'd say it's characterized by like a high number of concurrent operations, but each operation itself is pretty small. You're not sucking in a bunch of data and doing analytics and things like that on it. You're just like, inserting a single record or reading a row of records, a range of records, different things like that. So that's what Dynamo is good at. The number one thing about Dynamo and sort of what it promises is consistent performance at any scale. So if you're building an application and you want to, again, create that user or read the last 10 orders for a user, it should perform the same if you have a gigabyte of data, 100 gigs, a terabyte, 10 terabytes of data. It shouldn't really matter how much data you have. You should have the same consistent performance in that. So it's very predictable in that way, which is super nice. I mean, the big way it's doing that is just horizontal sharding of your data. So it's rather than having all your data on one big machine that's getting bigger and bigger over time, it's gonna chunk up your data into smaller partitions, 10 gigabytes or less, and sort of route your data based on a specific partition key. So you'll sort of say, hey, this is how I wanna split up my data. Dynamo is going to do that for you. And then as your data grows, they can add more and more partitions. You get that consistent performance over time. And again, this is like the core of your application. Like what your application does, right, is mostly going to be these known access patterns that you're doing a lot of times per second.
Awesome. So then that's the way it does it. How does it do it? So are we writing just like, we're setting up a table, defining a table with a bunch of columns, creating a DDL and a schema and writing rows, or what exactly is happening?
Yeah, not quite, right? So it's a NoSQL database, which is like kind of a giant grab bag of different databases, and I would say like some NoSQL databases are like almost all the way in the SQL camp now. So, but Dynamo is like a pretty unique in the database world, and like it doesn't have a query planner at all. So like most databases, whether that's any of your traditional SQL databases or even like MongoDB, you're going to issue a query for it. It's going to look at table statistics or figure out some way to like most efficiently execute that query and go do it. Whereas Dynamo, it's more like you have access to an infinite hash map or like a B tree, right? It's just like giving you almost direct access to like these core data structures that you're doing. So you're not going to define a full schema for your application. When you create your table, you will specify what's called your primary key, which can have either one or two elements. It can be a simple primary key with just a partition key, or a composite primary key, which has a partition key and a sort key. And that's basically saying, hey, how do I want to split my data, right? If Dynamo is chunking your data into these little 10 gig partitions all over the place, that partition key is sort of saying, hey, this is where that data is going. So when you make a request to Dynamo, it's going to look at that partition key, it's going to hash it, and then assign it to a given storage node based on that partition key. So that primary key that you specify is super important, right? You have to think about, hey, how am I going to access my data? How do I uniquely identify my data? And that's sort of splitting your data, maybe sorting your data, grouping it in different ways like that is what you're doing. But you won't specify the full schema. You're sort of in charge of managing the rest of your schema. You're gonna have to do that in your application code instead.
Oh, everything sounds awesome, right? It's like, so it's super fast, low latency, high concurrency. I can scale infinitely. I don't have to worry about defining a schema. I guess I have to worry about the partitioning and primary key. So, everything sounds dandy. I think I can build anything on this. First question that then comes to mind is, how about, you said NoSQL. So sometimes they're thinking, well, do I have to worry about ACID transactions, eventual consistency? Like, how does that part work?
Yeah, that's a good question. So Dynamo does have transactions now. I'd say like early NoSQL databases, they're like, hey, we don't have transactions. You're sort of operating on a single record at a time. Over time, these databases have added in transactions. Dynamo's had them for 5 or 6 years now. You still shouldn't use them that much. It's going to be a slower, a higher latency operation that you have there. There's going to be like potential contention around that. So if you don't want to be doing transactions on contentious items, but you can do transactions if you need them. So it has that. In terms of eventual consistency, yes, Dynamo has that as well. In certain cases, there's a lot of like nuance there on how that works, but basically, let's see, what's the best way to. Dynamo is splitting your data into these partitions, right? So you have these partitions. Each partition is actually a group of 3 storage nodes to give you some durability, availability, and just different things like that. So when a write comes in, it's going to get assigned to a partition. That partition is going to have a leader node, and that's going to accept that write, commit it, and send it to the 2 follower nodes and make sure that at least one of those commits it as well. And once that's committed, then it's going to return the client and say, hey, we accepted your write and good to go there. So it's got this strong leader model within that partition. I think there are 2 things that fall out of this. One, when you're doing a write to Dynamo, you're always seeing the latest version of the item. So you have what's called linearizability with writes, right? You don't have like multiple versions of an item, which is something that you'd see like in Cassandra, sort of where I think that's where the consistency model was really tough for people moving to NoSQL. Is like, hey, you could actually have different versions of items at different times. But when you're doing reads to Dynamo, you issue a read to Dynamo, you can choose, hey, send it to that leader node to give me the most recent version of that item. Or you can say, hey, for a cheaper operation, just send it randomly to one of those 3 nodes to handle that read. And if it happens to be that 3rd node that hasn't committed that latest version of the item, if you just time that sort of right, you could get like a slightly out of date version of that item. So there's a lot of nuance on that, but I think the biggest thing is, hey, when you're writing items, if you have condition expressions, if you're saying update this only if this particular thing is true, you're looking at the latest version of the item. That's great. But then sometimes when you're reading, you could potentially have like a slightly stale version of the item.
Awesome. But you have control over that, right? You can decide, I want it to be a little slower or costlier, take me to the leader, or you know what, make it fast and I might have a dirty read, but it's up to you and you have that control, right?
Yep. You do have that control with, again, let's add another caveat there. Dynamo has secondary indexes. So, hey, you have your primary key. You're mostly accessing your data in this particular way, right? But maybe you need to access it in a different way, right? Your users, you partition them by username, but you also want to find them by email address. You can create a secondary index, which is just like a copy of your data that's split up by a different primary key now. Now you can have email be your partition key to find that. If you're using a secondary index, and specifically a global secondary index, those writes are happening asynchronously. So they're not happening on the hot write path, which keeps your original writes fast. But it means that reads from that global secondary index are more likely to be a little bit behind, a little more behind than they would be from your main table. And also you can't opt into a strongly consistent read from a global secondary index.
Okay, cool. So I mean, some caveats, but overall, sounds like an amazing database to build really fast applications on. So why don't I just build everything on it, right? At what point do I start running into challenges or issues with DynamoDB? What kind of things does it struggle with?
Yep. I like to say there are like, so Dynamo's great at classic OLTP. I like to say there's like two areas where it's not great at, right? And that would be reading large amounts of data, because classic OLTP, you're reading and writing just small bits of data at a time. But if you want to read large amounts of data and do especially like aggregations on it, Dynamo is not going to be great at that. It doesn't have any out of the box aggregation features. And even like when you're reading bulk data, you can only read a meg at a time. So it's really not great for sort of aggregation stuff. The second area is what I call like flexible patterns, right? So if you have like Dynamo's good at known access patterns where hey, I'm going to be creating this user, I'm going to access it by its username, and so I can set that into my primary key. But if you have like all these different flexible ways you want to access your items, that's a little trickier for Dynamo. So that's like the broad thing. Hey, large amounts of data, unknown access patterns. What it looks like in practice, like sort of the three categories would be, hey, number one, aggregations, right? Whether that's internal analytics where I want to explore my data and tell my boss, hey, this is how many orders we had last month or last week or yesterday, and are we growing over time? Internal analytics, that's tough for Dynamo. I'm not going to be good at doing that. Also, user-facing analytics, right? Which is going to be a smaller amount of data, but still like a large amount of data, and you want to show something to your users. Hey, how many orders have you specifically made over the last month or the last week or whatever? Things like that. So analytics, not going to be a great one, whether that's internal or user facing. The second one is what I call complex filtering, which is think of like an admin view, right? Where you have maybe all your users or all your orders. They have all these different columns, and some support person wants to filter by all these different attributes, right? You have 10, 20 different columns, and you want to be able to filter by any of them at a given time. Like Dynamo is good at these known access patterns, but if you have 2 or more filters, all of which can be optional, that can be tricky for Dynamo to handle. So I call that complex filtering. And the last practical category is full text search, which is kind of just like a supercharged version of complex filtering where you're filtering on every single character within a field, right? So that's gonna be tricky for Dynamo as well. So really aggregations, complex filtering, full text search is where Dynamo is gonna fall down.
Alrighty. So then what happens when someone wants to do one of those things? Can't AWS just update DynamoDB and enhance it to add these capabilities, right? Why can't I just have some meta layer that queries a bunch of things, with a particular filter that I apply, or find me everything that looks like this? I'm sure AWS can do that, can't they?
Yeah, sure. I mean, because like most databases do give you that choice and just say like, hey, here's SQL or here's the Mongo query language, and you can just do a lot of different things in it, right? And again, it's going to have like that query planner that's going to figure out, hey, how do I handle this query and execute it for this person? I think the big thing that a query planner inserts is just unpredictability around latency. Right now, you assign a query, and now it's based on that data you have. That could be reading. You could be doing a full table scan, and maybe you're looking at gigabytes or terabytes of data for that, or you're doing complex joins and filtering and all those different things. So again, Dynamo's like product North Star is consistent performance at any scale. And it's like, that's the number one thing Dynamo wants to give you, is like, no matter how big your data set is, a single request to Dynamo is going to take sort of like this bounded amount of time, and you won't be waiting for seconds for it to like churn through a bunch of rows and things like that. So get like all those things, analytics, you're reading a bunch of data from disk, you're doing a bunch of compute on it. Complex filtering, again, if you don't have the right indexes, you're just like reading a bunch of data and doing a lot of work there. Full text search, same thing. All those are like unbounded type operations, which just add unpredictability. And Dynamo is like, hey, we're not in that game, right? There's a bunch of other databases that are in that game. Dynamo's like, hey, we're doing this one thing and doing it super well. And not only do you get that predictability, but you get like a really nice operational experience where like Dynamo is not going to go down. It's really hard to like overload Dynamo to the point where it goes down. Like what will happen is you might get throttled if you're not paying enough, or if you're issuing too many queries to like a single storage partition, they might throttle you back, but it's not going to take down the service, which is a really nice operational experience.
Cool. I mean, well, it's nice to know that I can't really kill it, right? Now, I might
Yeah.
pay a lot of money, but I can't really kill it. So I might try all kinds of ways to work around this problem, try to make it work, try to, get those features out and build them out because my users are asking for them, my product managers are asking for them. So I'll figure out how to build it in there. But, if at the end of the day it can't really handle it, well, what can I do? When I'm looking at the AWS ecosystem, right? Let's assume I'm, AWS certified and I know all the tools. What do you pull out of your toolbox to try to solve for these, right? These three areas, the filtering, the analytics, and the search.
Yeah, again, I think it's useful to think up front, like what problem am I trying to solve? I think the first one that comes up for a lot of people is just internal analytics, where my PM or my exec suite or whatever, they want to know, are we growing? Like how many things are we doing? Just, whether it's for investor updates or board meetings or whatever. So you're trying to do some internal analytics. I think that's potentially like an easier problem to solve just because you have looser constraints, right? It's not going to be doing 100 requests per second. It's not going to have very tight bounds on latency and things like that. It's just like, hey, we need to make sure we have these numbers. We can run them for a board meeting or a dashboard where it's okay if it takes a little while. So like options there would be, hey, easiest one is Dynamo has an export to S3 feature. So you can basically just export your entire database to S3. Dynamo will do that in the background. They'll charge you a per gigabyte rate for that. And then you can use what's called AWS Athena, which is just like a distributed query engine that works on object storage like S3. And like you can write SQL, it's going to like suck up those files, do the SQL processing for you, and then return a result. So that's like fairly straightforward. I would say the big downside of that is how often you're going to be exporting your whole table. They do have incremental export now, which is easier, but you're still like dealing with some complexities around that. So that's number one. Another one for internal analytics, if you need something a little bit faster, but still like internal, you can look at Amazon Redshift, which is just like a, MPP, OLAP processing engine that you can do for that. Those would be like the two analytics, the internal analytics focused ones. If you need something a little more responsive and especially user facing, then you're probably looking at OpenSearch, which is like the AWS fork of Elasticsearch, which has its own like interesting characteristics, I would say.
Okay, yeah. Well, how about, there's a pattern that I've seen before and I've done with other systems that are similar to this. Why can't I, for example, take a Lambda and, take windows of data streaming out of DynamoDB and then writing those, pre-aggregated results back to DynamoDB? Yep. Like, won't that give me the speed, the performance, and the user-facing aspect?
That's a good question. That's a good point. Like if you have analytics that's pretty well known, so you're like, hey, I want to be able to show, again, let's look at orders, the sum of orders for a given store each day. Well, yeah, now as orders come in, Dynamo has a feature called Dynamo Streams, which is just like a change log of all the operations that happen in Dynamo. And you can just sort of like take that, and when an order comes in, you just grab it, you add it to like the aggregated stored record for that day and have it. And now you've turned what could be unbound, like an ON lookup across all these potential orders. Now you have like an O1 lookup to say, hey, what's the total amount for this day? So if you have like narrowly scoped, like well-defined, again, if you're in like well-defined access pattern land with your analytics, where you're just like, hey, I want to know, for the day or for the month or whatever, how much that is, that's doable. I think the harder part is a lot of times your analytics stuff is like, we're just like so used to being able to like click around and do our own sort of slicing and dicing of data, like not just internal analytics, like apps that we run, right? Like we want to look at our transactions, be able to like filter out certain things and still do aggregations based on those filters and things like that. I think we've just gotten used to that, and that's a lot harder with Dynamo.
Got it. Okay. Now, you were mentioning OpenSearch, right? And OpenSearch as a way to handle some of these use cases. And over the past year, I've been hearing, past 2 years, I've been hearing a lot about, zero ETL and OpenSearch. What problems does that solve for me? And, where does OpenSearch actually work great? But, you said that it doesn't always work great. So what are the issues there with saying, okay, OpenSearch is a solution and zero ETL is another amazing thing?
Yep. That's good. I'm trying to think where to start there. Let's come back to the zero ETL port, like how the data gets into OpenSearch. Let me talk about OpenSearch itself. Man, OpenSearch, like I'd say OpenSearch is like almost like the opposite of Dynamo, where it'll let you do almost anything. Whereas Dynamo has like these strict bounds and what you can do, and because that can give you like this very strict performance and operational profile that are very nice. Elastic/OpenSearch will let you do almost anything, issue any type of query. You can handle that and distribute it across a bunch of different nodes. But I think it's hard to understand the performance profile of any query, especially as your data grows. I think operationally, personally, Elasticsearch is like the last thing I ever want to operate again. Just because like where Dynamo will start throttling you if you're hitting it too hard or if you're not paying enough, Elasticsearch will just like take in request, and then just fall over and die. And now you have to like rebuild your entire index and you've lost like a whole day. So I'd say those are the big things. Also, if you look at those like three categories of areas where Dynamo doesn't work, I would say Elastic is very good at the full text search aspect. It's pretty good at like the complex filtering where it's like, hey, fetch me a set of records that have these specific characteristics. The analytics stuff it can do, but you have to be really careful because it's just like, so it sort of chews up a lot of memory and just different resources on Elastic. And that's where you really get into like noisy neighbor problems, not noisy neighbor problems within your Elasticsearch cluster, right? If someone's issuing queries against that's doing a lot of data, it can really affect what's happening with others. I remember, just story time, I worked at a place and we had a lot of user-facing Elasticsearch time series like data, right? Where we're doing these like lots of little queries. But then also the boss of the place, he wanted to have his own dashboard that showed like, hey, how many new records are we taking in? Like all these different things. So he made this dashboard that had like 20 different panels in it. And whenever he would like open his dashboard, it'd fire off like these 20 giant aggregations across our entire Elasticsearch data set. And now we're like, just every time that happened, we just get error, like alarms because it was blocking all of our user-facing queries, like chewing up all those resources and things like that. So we had to tell them like, you cannot open this dashboard, or if you do, it has to be like overnight. You can't do it like in the middle of the day. So like, that's the big thing. Like, what are you trying to solve? If it's full text search, hey, that's what Elastic's really good at, Elastic/OpenSearch. But I think just be like prepared for, I think, the operational burden of that. Like even a managed service like OpenSearch, it's not managed like Dynamo is managed, in the sense that like it can really go down. Like you have to sort of pay attention to CPU and memory usage and things like that, where like CPU and memory is not even shown to you in Dynamo because it's like not your problem at all.
That's interesting. It's like the fact that it's not a problem at all. So there's even no need to use to even see it. I think that's an interesting litmus test. If they show me no metrics, no CPU, no memory, assuming all the best intentions, right? Because it might be, it looks so bad that we don't want to show this to you. It might be a litmus test that says, hey, this thing's so awesome, I don't even have to worry about that, right?
Yeah. Awesome in the sense, like, again, like I love Dynamo, but again, it prescribes what you do.
Yes.
And there's so little like when you issue a query to Dynamo, you're just like limited on how much CPU and memory and disk IO you can actually do. So it's like, they've sort of just like taken on that burden. It's like, hey, we'll filter you at some level to understand if you're exceeding limits, but you don't have to think about CPU and memory pressure and things like that.
Awesome. I mean, that's very helpful. Really, I guess those guardrails are what allow it to give you the latency and concurrency and infinite scalability guarantees, right? They're like, look, at the end of the day, you have to give you have to give a little to get a little at some point.
Yeah.
Right.
Yeah.
Cool. So OpenSearch starts having issues if I start running all kinds of big queries, all kinds of big filters. Don't give your boss a big dashboard that can bring down the entire cluster. But if you want to do full text search, it's spectacular for that. And I think that's what it's really good for. So then we've tackled one of the three problems. How do I tackle the other three problems then? And the other two problems, complex filtering and analytics, what are my options?
Yeah, I mean that's what we're here for today. Like Tinybird is a really good fit for this thing. Tinybird running ClickHouse in the background. And basically what you want is like some sort of, probably columnar-based data store, distributed depending on how that on certain things, but like something that's optimized for reading a lot of data quickly, being able to process data, but also like structuring data in a way that allows for filtering on like sort of larger data set type things, right? Where Dynamo is going to be row based and sort of specified on specific keys. Something like ClickHouse is going to be columnar and organized in different ways to like allow for those sorts of things. So yeah, that's what I that's what we're here to look at here. And yeah, I used to recommend a tool called Rockset, which was sort of similar, and now they've been acquired by OpenAI. Hey, congrats to them. So and then like now Tinybird ClickHouse is like the best next solution I've found, which is great. I'd love to see this.
Cool. So I mean, so you talk about Tinybird and ClickHouse, right? And to for the audience to clarify the distinction, Tinybird is a database that is is a streaming database and batch database. It can allow you to do low latency, high concurrency queries, especially analytical queries. So it is an OLAP data store. Under the hood, it's powered by ClickHouse, right? So that's a major portion of how we achieve that speed. And Alex was talking about that, the columnar approach of it, the fact that ClickHouse is one of the fastest databases. So that's what it gives Tinybird its ability to be so fast. However, we have so many other capabilities that we've built on top of the platform and on top of ClickHouse as the core database to really make it an amazing and actually, pleasant experience for developing low latency, high concurrency experiences by building off of analytic queries. So Tinybird sounds awesome, but then how does that work with DynamoDB, right? Do I have to start building ETLs? Pipelines, right? Do I have to copy data over? Like, how do I get the data over to Tinybird?
Yep, sure thing. And one thing I should have mentioned too, like it made me think about it as you're saying, it's like just how Dynamo makes like very specific trade-offs on like, hey, you can't do this, and because of that you get these things. I think Tinybird does the same thing, right? Like you can't do transactional writes against ClickHouse, or against Tinybird. You're not going to be using it for your core data store of just like recording an individual order, or making sure this user, like creating this user if they don't already exist, right? They're taking that trade-off. You're mostly doing like streaming or batch ingestion, like you're saying. But because of that, now you can do low latency, high concurrency OLAP queries, which is like super powerful.
Cool. And then can we try to explain, at least in your words, the difference between an OLTP query and like or an OLTP workload and an OLAP workload? I had one of my salespeople come up with an awesome way of explaining it, and I've been hunting for other ways of explaining it. But in your words, what's the difference between an OLAP workload and an OLTP workload?
Yeah, it's interesting because like, especially when I think of traditional, I mean, I guess like OLTP is going to be like, again, a large number of concurrent operations, but small amounts of data, right? Creating an individual record, reading an individual record, maybe 5 or 10 records, different things like that. But again, small amounts of data, very low latency, want to be able to maintain constraints. OLAP is going to be looking at, hey, we have a lot of data across our whole data set. We want to be able to like aggregate this, filter out certain ones, group them together, sum this particular value, order it by this thing, and show me the last 10, right? Which might be talking about like gigs of data to be looking at. So like, again, it's like one would be if I go to Amazon and create an order, that's OLTP. If the Amazon PM goes in and looks at the most popular products ordered in the United States over the last week by category, something like that, that's going to be an OLAP workload, right? Like how much data are you sort of looking at in a given request?
Awesome. Okay, I think that covers it really well. I mean, that really explains it well. My challenge and my fun part is taking it even simpler in a way that I can explain it to a non-technical person.
Sure.
And this is the way I explain concepts to my wife, who is technical in a very different way. She's a dancer. This whole technology stuff, like, especially hardcore database stuff, takes me a while to explain. And I took this from my salesperson, which is OLTP is find me one specific tree in a forest, find me this specific tree in the entire forest. And then OLAP is find me every tree that's taller than 20 meters, has green leaves, and only has 77 leaves on the tree, right?
Yeah.
Find me all the ones that match that pattern. And so that's the way I can explain to her. Is like, and those are very, very different workloads.
Yeah.
And it takes very different database architectures to be able to handle both of those very well.
That's
awesome.
great.
So then Tinybird can do this. Tinybird is great as OLAP. Then, so it can solve both the analytical and the filtering challenges, or is it good at one versus the other?
I mean, you would know better than I would, but yes, I believe so. Like, hey, it's going to be able to like, it's basically designed for filtering it, like going through your giant set, filtering out based on these different conditions, and then also being able to merge those, do aggregations if needed. So I would say, like, the way I would rank it, or I would say it's almost the inverse of Elasticsearch or OpenSearch, where it's like, hey, really good at analytical type stuff, pretty darn good at complex filtering too. Full text search can do, but you're not going to be like sort of as powerful as a more dedicated search engine.
Got it.
Is that how you sort of look at it?
Yeah, no, I think I look at it the same way. Definitely where, Tinybird can do full text search. It's not what it's built for, and it's not amazing at it, but it can do it, right? And if you need to shoehorn it in, and if you want to, if you want to limit the sprawl of technologies, if your core use case is analytics, but you need to do full text search, I'd absolutely go with Tinybird. If it's the flip side of that, the inverse, if I have my core use case is full text search, and then I have to do some analytics, I'd probably go with OpenSearch as well, right? Because I focus on my core use case and do some of the other ones. Although that concern of I'm going to kill the server if I take too many of the analytical queries, that makes me a little scared, right? And because then I've got something in my architecture. I really can't kill DynamoDB. I might kill OpenSearch, so I might be in trouble, right?
Yeah.
I think this is one where I think Tinybird probably wins out, where at least the way we've set it up, the way we've architected, is really hard for you to kill Tinybird. And it's not anything special about the database under the hood. It's the amount of engineering that our product team has built in, because the philosophy of our founding team was we want to build the fastest OLAP database in the planet that's extremely easy to develop on. So it's the fastest development experience on the planet. To get that second piece on it, we've had to really abstract away and remove a lot of the complexity, a lot of the headaches, and a lot of the things that you have to do with managing a powerful database like ClickHouse under the hood. So in practice, really, really hard to kill Tinybird, because we do everything possible to prevent you from killing it. And we work on scaling it and operating it. Obviously, we've got a way to go there. We can do even better and better. But I think that's a leg up over that OpenSearch problem, where I won't worry when the boss shoots off a bunch of full text search queries. I'm not concerned that we're going to kill the database.
Yeah. And shout out to you for doing that, because I remember, like, my first job in tech was data engineering. We did a bunch of Redshift work. And I remember ClickHouse was like just coming out. We tried setting it up and all this sort of stuff. And I was like, this thing is super fast and powerful, but I was like scared of running it myself, especially, especially 8 years ago when I was trying that. But it's like, props to y'all for like figuring out and putting some resilience and just like ease of use around it.
Cool. And and that's the thing, our motto is speed wins, right? And we believe speed wins in every dimension. Speed on your queries, speed on your development experience, speed on your flow. It's just we make it easy to go from idea to solution as fast as possible. And then you don't have to worry about the amount of data. You will get the low latency just like you will with DynamoDB on the OLTP side. You'll get the high concurrency just like DynamoDB on that side. I think we've got a little bit more to go at any scale and independently. You'll never have to worry. But we're going in that direction, right? We're pretty close. We're not too far from that. So I think it's a really good partnership and marriage, and like putting them next to each other. So I'm looking forward to getting there. We're getting there.
Yeah, for sure.
So I
want to go back to So the open ETL or like the how do I get it into Tinybird or like OpenSearch? They have a zero ETL solution, and you sort of mentioned the you are consumed with speed, not just speed of query, but like speed of flow and just being able to get stuff done. And that's where, so Dynamo gives you, I think Dynamo realizes, hey, Dynamo's good at these things, but it's not good at other things. In the last 5 years, they've made it a lot easier to get data out of Dynamo and put it into a system that does do those things well. So they've had DynamoDB streams for actually a while now, longer than 5 years, which again is just a change log of what's happening in your database, right? It's this ordered log where every time you do a write operation, they're going to put it into that log, and you process it just like any other stream abstraction, like Kafka or Kinesis or anything like that. But often what happens is, hey, you're building your Dynamo database, you've done that, maybe you have streams enabled, and then a year down the road, sometime down the road, you're like, hey, we want to enable these other things. You need another database for that, but we already have 10 gigs or 100 gigs or how much data in our Dynamo table. Like, how do we sort of get that out? And so now Dynamo has an export option, export that data to S3. And so what you're seeing with zero ETL and with the Tinybird connection is you can basically go to an existing DynamoDB table, make sure your stream has started. So now anything from now on, every single change is going to be reflected in that stream. You do an initial export of your data, and it basically exports that data to S3. That's your sort of snapshot, your previous data. That gets ingested into OpenSearch or into Tinybird. And then once all that ingestion has happened, now it starts processing from that stream and saying every single operation that comes in, now go apply it to our secondary database, whether that's Tinybird or OpenSearch like that. So you have like this initial export plus like a continuing ongoing changelog that like keeps you up to date from there. And again, it just like makes it so much easier to test out adding these sorts of things where it's like, hey, I have this existing database. You could sort of schlep this stuff together before, but now it just like makes it a lot easier for you. You can do that export, you do that stream processing, and you're good to go.
Cool. So, I mean, it looks a lot more, at least it seems like it'll keep everything up to date more than the previous approaches you talked about, right? In the past, you said we can dump everything into S3, but then I have to worry about how often I'd be dumping it into S3 to then re-ingest. So I need to schedule a cron there and it'll never be up to date. But I think the idea that I get a snapshot and then the stream from that snapshot onward, it means I'm always up to date. It means I'm keeping up with it in real time. And I can see what's in Dynamo over on the other side with the zero ETL approach.
Yep. Yeah. And I used to recommend people like do that themselves before like the export tool, or especially like the good connectors came out. I was just like, hey, it's kind of a bummer. What you have to do is you have to like scan over your table and export all that and then start processing your stream yourself. And it turns out there's just like a lot of complexities around that, especially like more of these OLAP databases, updates are kind of harder. They also don't want to do like individual inserts and updates and deletes. They want to sort of batch them together in some sense and do that. So just like if you're maintaining that pipeline, there's just like a lot of ways it can go wrong. Again, I like my first job was as a data engineer, and data pipelines are just like not fun to maintain because it's like you set it up once, there's no glory in it later on. Like the only thing that can happen is that it goes wrong. So it's like you really want to like maintain as little of that as possible for these sorts of things.
Cool. And then I think this I can say from DynamoDB connector, and I know you've played with it and use it. We 1000% agree, right? We don't, maintaining data pipelines are a headache, and maintaining data pipelines make you slow. It goes against that idea of speed wins. And when it breaks, Lord help you to try to fix that and resolve that. That's why we love this idea that AWS has been going down the zero ETL path. And we said, hey, we can do the same. So on the Tinybird side, you say you want a DynamoDB connector, you just configure and say, I want a DynamoDB connector, set it up. You have to go on the AWS side and then enable the two pieces of it, which is the stream and the point in time recovery. But you enable that on AWS, you turn it on in Tinybird, and data starts flowing. And that's it. No pipelines, nothing to manage, and the connector does it for you. I think that's amazing in terms of just taking that weight off your shoulders, right? Removing that complexity.
Yeah. I love that aspect, and especially like again, you can set this up in like you set it up. A couple hours later, depending on how big your data set is, it's like completely ready and going. And now you can like start hammering queries against it to explore it. You can start actually like building it into features and just like, you're not maintaining this data pipeline forever.
Cool. So, I mean, just like, Dynamo was sounding amazing before, and you're like, hold on, wait a minute. It doesn't solve everything. Tinybird sounding pretty amazing, right? I can press the button, I can start getting data in, I can start writing analytical queries and all this other stuff. What would you say then potentially are some things that are missing? From your experience and the things you've done with the DynamoDB data in Tinybird, what would you probably want to see in there? What are the things you'd love to do there or see on the Tinybird side to make that experience even better?
Yep, good. Now I'm going to put you on the hot seat and ask. So I guess like from talking with clients, and I remember like when I would recommend Rockset to folks a lot, I think the number one question I would get is just about it not being AWS native or not provided by AWS. And so I guess a couple questions I have are like being a third-party vendor. Number one, can I know you can choose the AWS region or GCP region if that's what you're using that Tinybird is in, but can I actually like host it in my account or have a managed thing in my account? Or hey, do you have AWS marketplace integration where if I already have a billing plan with AWS, I can pay for Tinybird through that, use it towards my committed spend?
Got it. So we run on AWS. Yes, we're in a few regions. We're not in all regions. And, we open more regions depending on how many customers are demanding them there and are asking for them there. But we're definitely on AWS US East 1, and I believe on US West 1, if I'm not mistaken, or West 2. I've got
and I think EU too. EU Central one is that?
Oh, and an EU Central as well. Yes, I was thinking US centric, right? But EU Central.
Okay,
So we've got one at least in Europe. We've got 2 in the US. And obviously, we keep opening up more based on customer demand, different parts of the world. In terms of running it in your own account, we don't do that yet. At the moment, Tinybird is a fully hosted SaaS solution, and we run on our side. We've had some of the bigger customers ask for that. It's something that's just much more complex, a lot more difficult. And you also lose a lot of that flexibility and a lot of the power that we give to you. Just like that same question you had, the same thing you said, I kind of don't have to worry about the memory and CPU and all that throughput. Not 1,000% true on the Tinybird side. We help you watch that so you can determine when to scale up and when to scale down. But there's a lot of that you lose by moving it onto your own infrastructure. But the marketplace question, that's actually a really good one. We actually we can work through the marketplace. So if you've got a committed spend on AWS, you can absolutely apply that to Tinybird and contract through the AWS marketplace. So you can apply that committed spend through your Tinybird use.
Yep. Okay, perfect. I also see some questions like sort of in the comments that are related to what I would do. So I'll skip to one of those. Like I know a lot of people using Dynamo are also doing like serverless stuff or very cloud native stuff and use infrastructure as code. Is there any infrastructure as code setup or integration with Tinybird?
At the moment, we don't have infrastructure as code, at least the way people think about it, like with CloudFormation or Terraform. We use that internally as we're deploying and managing things, and we're always thinking about how to expose this to customers who want to use this to more infrastructure as code. However, we really do have a very robust CICD integration where everything in your Tinybird project can be defined as Git files. We have these kinds of files called data files. So all your data sources, your connectors, your connections, your pipes, and the code, and everything you publish in Tinybird, you can actually manage that as a project, put that in Git, and through GitHub Actions, or whether you're in GitLab or somewhere else, use your entire CI/CD flow to validate that, to branch it, to confirm it, make sure it works, and then deploy it. So you can automate the deployment of all the code in Tinybird. So that is the closest we get to infrastructure as code.
That's
so we're not
pretty
fully
close
there,
to what I want.
really
I think the big thing I'm worried about is like, hey, did some engineer 3 years ago go and click around in some console, and now 3 years later, that person's gone. We don't know how to reset this stuff up. It's like, don't touch the whole environment. So yeah, like that's pretty close to what I wanted. Like there's some sort of code-driven way to maintain.
It's reproducibility, right? Reproducibility and repeatability. Like you can tear down the whole project and redeploy it, and you've got the same thing all over again. That we definitely have.
Yep. Okay, another question I had, looking at limits that you have, currently it says limit of 250 WCUs for Dynamo. Is that a hard limit? Is that, I guess, what happens if I have a table that's doing more than that? What does that look like?
So, and just to clarify, that limit is the limit for how big your DynamoDB table is and how much we can ingest on one connector. At the end of the day, I think almost every limit that we have, we ask a customer, hey, come talk to us. We haven't found any customers that have had, and we've pulled in some massive tables from DynamoDB for the customers that brought that in. I think the limits are more to really protect your infrastructure. When you're on shared infrastructure, protect all the other customers on the shared infrastructure. But again, almost every question comes to, what are you really trying to do? Is that the best way? And we might have to lift the limits, and we'll talk about that. Are there any commercial ramifications to that or anything else that we have to think about? But that is primarily to protect our infrastructure, your infrastructure, and the shared infrastructure so that the whole thing doesn't destabilize and fall over. And also, the other piece is this, one thing that people don't realize is when you do an initial setup with DynamoDB, the DynamoDB connector, there's the point-in-time recovery and the streaming. The streaming can start immediately, but that point-in-time recovery, that can take forever on the AWS side. So if you tell me you have this massive table, let's call it terabytes, and you say, great, send it to Tinybird, you might think that Tinybird is just taking forever. It's like, well, not exactly. That's not how it works. AWS is working on that, putting it on their queue, giving you the entire snapshot, writing it to S3, and then we can grab it and pick it up. So there's some controls there also to manage your experience and your expectations.
Yep, for sure. Okay, last question I have, again, I know we got to get to the demo, but a lot of folks with Dynamo use single table design. They're putting multiple different entity types in a single Dynamo table. What sort of tools, or what do I have within Tinybird to sort of, unmerge those, or make it more sort of queryable in an analytics way?
Absolutely. So, with the single table design, what you're getting is this massive JSON blob that's going to land inside of Tinybird as one big blob. So generally what we do with those is First, we understand and capture that CDC stream. And the beauty is when we go through this demo, we're going to see what that looks like. We capture that CDC stream as a raw blob. We'll pull out the key columns that help us organize the data, index the data, and make querying very fast. But then we have this capability in Tinybird called pipes. At the end of the day, almost every unit of work in Tinybird is a pipe. A pipe is just a collection of SQL that lets you transform data, move data around, aggregate data, and then expose it as a solution. That solution could be take data from this source, parse it, process it, write it to that data source, write it to a table, take data from this source, write it, parse it, aggregate it, and export it down to S3 again, or export it to something else. And the key use case that people do the most is take this, query it, process it, and then expose it as an API straight to your client app that is highly concurrent and low latency. So at the end of the day, you have SQL. You can take SQL to process all this JSON, parse this JSON, and split it out every way you want it. You can normalize it, and you can denormalize it. You can stick it on tables and columns. So that's what Tinybird helps you do with these single table designs.
Yep, gotcha. Okay, I have a bunch of other questions. I know we want to get to the demo too, so if we have time at the end, I'll come back with more of these. Yeah.
Cool, awesome. So yeah, let's definitely do that. So thank you for that. I'm going to switch right now, and the demo that we're going to do right now is Alex is actually going to walk us through a sample app. I don't have the sample. Actually, I have the sample app in my background, but I'll let Alex just go on this. So this is a sample app that we had built to capture a bunch of flights. So what we have is a flight demo. In here, we have a bunch of customers booking flights, and they're booking them across, a few airlines. And then they're booking this on DynamoDB, right? We built it on DynamoDB because we didn't want to worry about scale. And really, when you're creating a flight record, that's one record. I just purchased a flight. I might have to do some updates. I'm doing point updates. But then I want to start creating aggregates and analytics over this data. I wanted to see, how many bags do customers buy on their flights? I want to see which airline has the most trips, which customer is the one that travels the most. And that was really hard on DynamoDB. So we set up a connector. So in this demo here, this is Tinybird. You're seeing the dashboard. In this connector, DynamoDB data is already streaming, and I'm clicking buttons on the flight app, and data is actually streaming in right now in real time. I think if you go, Alex, to the DDDB flights connector data source at the bottom, I think you might start seeing that data starts flowing in, and that was me like about an hour ago playing with data. So pretty soon you start seeing other spikes there, but data is flowing in real time. But I think the idea here is, there you go. See, there's the data flowing in. So DynamoDB is getting pounded with data, and that data is flowing in real time to Tinybird. So now I think the cool thing is going to be, Alex, can we build a new API? I'd like to see a new aggregation, and how quickly can we build a new API with Tinybird on top of your DynamoDB data?
Yep, for sure. So I played around a little bit. The first thing I want to do is just explore the data a little bit. So I looked at this. I went to schema, which is nice. This shows me just sort of the data set that I'm working with, the different columns that we have here. So you see things like age, airline, email, different things like that. When I was looking at this, I was like, oh, this is a great groupable thing. Airline, all these flights from an airline. Also name, hey, we got the given passenger. How many sort of flights have they taken? So I wanted to explore the data, and I went to Playground, which is just hey, now I can write some SQL queries on this.
Actually, I mean, that's already cool, right? You can't write SQL over DynamoDB, and now you can write SQL on your DynamoDB data.
Yeah, especially this was one of my favorite. Back when I was doing data engineering, I would just use this query all the time. Basically select some value and count the number of records, right? Group by 1, so I'm grouping by airline. Order by 2, descending, limit 5, right? So that's going to just group by this airline and count how many we have, order by that, and show me the top 5, which is this problem in Dynamo is just impossible. It's oh yeah, you can do it's like the distributed MapReduce.
Awesome. Well, I just started sending more data. Can you refresh that and see, is this real data? Right.
Yep. So there you go. You see it Brian Ayers getting more. Yep.
Awesome.
Yep. So, yeah, very cool. So again, I just want to explore a little bit. Let's also do just names. So we'll look at passenger. Let's see if we have the same passengers showing up. Okay, yes, we have Rafa, Gonzalo, different things like that.
Rafa and Gonzalo like traveling a lot.
Oh, Elsie, this is my wife's name, and no one is named Elsie. It's it's starting to come back. So hey, how fun is that? Anyway, so I was looking at that, and I was figuring, okay, let's do some sort of aggregation related to the airline and different things like that. if I go back and look at that schema again, look at that. I see like flight from and flight to, so like the departure and arrival airport. So I decided I want to do some sort of aggregation by that. I'm going to create a new pipe here. You want to do flights connector, right? Final. Okay, and so what did I want to do? I want to do flight 2 and count. Does it matter? Just weird for ClickHouse. Does it matter if I do count star or should I do like count flight 2? Like, is that gonna?
No, you can do count. You can do count 1. Actually, I tend to do count 1 quite often.
Okay.
There is something specific. I don't know if count star is an issue, but here's one thing to remember, right? As a columnar database, it really matters how many columns you're querying, right? Versus how many rows. How many columns is very important. You can actually vastly reduce the amount of data scanned by selecting less columns. So count 1 doesn't even look at columns.
There you go. That's true. Okay. Yep. I'm been out of the game for that. Okay. So again, let's do group by flight 2, order by 2 descending, limit 10. So this is like, hey, some sort of aggregation I want to do. Actually, I want to do, let's add a where clause in there. Where airline equals, oh, I forgot the name. Was it Brian Air?
Yeah, I think it's Brian Air. Yeah, Brian Air.
Group by. Oh,
what did you just
where
do?
am I
Let's
missing
see.
something? I'm at 20. Why is it now by that?
You queried that a moment ago.
Yeah.
Because airline.
There we go. Oh, it was just a semicolon.
The semicolon.
Okay.
Oh yeah.
Yep. There we go. Okay. So now what I have here, it sounds like for this given airline, Brian Air, I can show, hey, what are the most popular arrival airports, right? So you can imagine like, hey, some airline exec or something like that, they want to say, hey, what are our most popular things? They could get something like that and get that to them in the application, right? And showing the top results there.
Cool. So I can build an API and expose that by Brian Air. So wait, hold on. How do I create an API out of this?
I think it's create API endpoint right here.
Cool. All right, let's give that pipe a name, right? At least.
Yeah. Sorry. Oopsie. I
think you need to have underscores in there, yeah, at the minimum. Cool. So that's a node. You can create an API endpoint. Sweet. And you're going to publish. Hey, confetti. We have an API, but what does that API look like? Right? I think you take that.
I believe if I take this, I don't know if this is going to work. If it's going to show.
It's not going to show it in this demo, right? Because it's going to be put that in the browser. But if you paste that into the browser, you're going to get the results. You're going to get those JSON results, the same results from the query. There you go.
So this is just. Is that right?
Yeah, we have an API.
Okay. Yeah. Right. So then, like from my actual front end, I could just query this directly and show that to end users, right? And empower. Whatever chart or other, number I want to display there.
Yeah. So now can we go back to Tinybird though? Like I'm only going to get Brian Air's data, right? In my UI, I probably want to filter by different ones. Yes. Do you remember how to do that in there, right?
Yeah.
I can give you the syntax, right?
I'm going to need help. Is it like this?
Yes. And string, define that as, the string and then open parentheses and just write airline.
Now it's doing it for me.
And then for that default value, just write Brian Air for now. Yeah, and let's try to run that right now and see what happens. I think you can leave that. Yeah, you can airline to filter by. Yep, awesome.
Okay, run that.
Sweet. So we got the same results, right? We're going for Brian Air, but can you scroll to the top? Here's something interesting that's happening. We've got a parameter in here. So now this actually tells you that this particular query is going to have a parameter. Can you view the API now? And I'm going to see if I have one of the other airlines.
Yeah.
The other airline names. Red space balloon is another airline. So yeah, if you copy that URL and then change that to space. Oh no, sorry, space. I mean like an actual space. Like it would be like a %20.
Right there.
Let's see. Run that.
Copy that.
Yeah, copy that and run that. Let's see what happens. I don't know if your browser will try to change it, but I think that's the red balloon query.
It worked.
Yeah.
Yes.
There you go. So now you have an
Different
API. I
results.
can probably code this and put this into my web app, right? I'll integrate it into my web app or my mobile app. And now I can pass in the airline name, Brian Air, Red Balloon, Lair Dingus, right? All these different things. Awesome.
Yep.
You've got an API. Wait,
I have a question for you. So is this
Yeah.
token, I know there's like a token that's basically saying, hey, you can call this from your front end. Here's the auth on it. Is that token going to be scoped to just this API? It's not like someone can go run select star on my Tinybird now. Is that right?
So actually, if you go back, that all depends on you. You can have all kinds of control of what kind of tokens you expose. So you can have tokens for an entire database, tokens for just one table. You can even have tokens scoped to one specific row. So you can put actual filter params and query params on a token. But there's another way to do this, right? So if you imagine most people who are building a web app are not going to want to expose their token on the UI. So there's another piece here. If you go to that output area, you see there says static. If you scroll to, you go to the right, there's a button there that says jot. So you can actually use your jot token instead. Now, if you see here, obviously it says token equals jot token. That's as the query params. You can actually, if I'm not mistaken, you could put that in your header params and use a bearer token and then have a backend handle that. But the beauty of this is the following, that if you now have a jot, you can actually control your access however you want. You can have your app generating jots. You send those out to if you're having your UI have a jot for authentication, you can send that same jot to us. And now we'll just use your authentication. You don't have to use our tokens. So it makes it much easier to integrate into a web app.
Very nice. Okay. Could I extract values from that jot to use as parameters, or is that too wild?
No, I don't think. Well, actually, at some point, we're not there yet. But what we're working on is trying to think about what are the things you can bake into the jot. Other things that we heard people put into the jot. For example, you want to do a multi-tenant app. You might want to bake the particular tenant ID and a few other params. So we're working through that in the documentation, and April can share some of that. We can definitely at the moment bake in like limits and with some throttling that we want to put in there. So that's in there. I've got to double check what other parameters can be put into the jot. I mean, Sebastian, who's been like commenting very, in the channel, it's awesome. Thank you, Seb. He's saying yes, we can. So he's ahead of me on that one. But the rate limits is what I was talking about before. You can add rate limits. So there's several things that we're building into the jot. So yeah, up to you. You can have your own mechanism for generating jots. You bake these things into there. Those are secured by your own keys. We can take that and then honor it.
Yeah. I love that. And then like you're saying now, again, if you have a multi-tenant app, now instead of passing up Brian Air, but then someone changes it to Red Balloon or whatever, you're just pulling it straight from that jot, so they can't get something inside of there.
And the cool thing is this: you've got a REST API, right? In that time frame, on that while you did that in the demo, right, which I love getting to, is you wrote a bit of SQL, your data's already flowing in there. You've got your DynamoDB data. You've just built a brand new API on your DynamoDB data that is ready to be integrated into your app, and that happened in minutes. Right? Imagine how many different APIs you can build and how quickly you can build applications, especially analytical applications, by not worrying about all the different pieces. You just write some SQL and publish it because your DynamoDB data is streaming right in. That's one of the things I like is really cool in Tinybird.
Yep. And you just, you don't have to build that backend. I love there's been like a move towards more just like client side calling data stuff. You have to, as long as you have the auth stuff figured out, but it's like, man, that really is like pretty slick to not have to worry about all the back end stuff and just hit this directly and get those results. I love it.
Cool. I mean, so that brings us in. That brings us all the way to the end. I mean, we've got 2 minutes left. And I wonder if there's any other questions that folks have come up with. And folks have come up with questions here, but with 2 minutes, I don't think we can do it justice, unfortunately. But what I want to do is this. Alex, this has been a great time with you. Thank you so much for dropping so much DynamoDB knowledge. And the frank discussion back and forth and things that it's good at, not great at, what OpenSearch is good at, not great at, and even Tinybird, what it's good at, what it's not great at. And then, letting me use you as a guinea pig to see how quickly you can build an API. So that was kind of fun. Are you going to be anywhere anytime soon? How can people find you? Any particular shout outs you want to make or anything you want to tell our audience about?
Yeah, first thing, Ariel, thanks for having me on. This is great and a lot of fun. I'll be at reInvent, AWS reInvent in Vegas in 2 weeks. So if people want to find me there, feel free to reach out. I'm on Twitter or email is easy to find. So hey, let's meet up. Other than that, if you have any questions about Dynamo, about just data in general, like you want to chat, let's do it. Happy to chat anytime.
Awesome. Very cool. So great. Folks, we're going to be at AWS reInvent as well. Come look for us there. April posted, which booth we're going to be at. So we're going to be there the entire week. We're going to be running fun challenges as well. So come by the booth, try to do some challenges, how quickly you can build something in Tinybird. If you're looking for more information, join our community on Slack. That'll be on our website. You want to come to Tinybird, you want to try it out and test it out, sign up. It's, you can create a free account with very, 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 very generous limits. So you can get going and testing and validating things. Set up your own DynamoDB connector and see how you can explore your data with SQL and create brand new APIs. So thank you, everybody. Thank you very much, Alex, for your time. Thank you for the questions in the channel. If you're going to have more questions, you want more questions, please feel free to post them in our community Slack. We'll happily answer them there. This has been awesome, and I'm looking forward to seeing you at reInvent and seeing the rest of you come by the booth. And thank you again, Alex. This has been great.
Cool. Thank you.
Thanks.
Daddy.
Yes, we are.
Can you play?
And my daughter came in right on time.
Can you?
Sorry, I'm going to get out of here.
8 o'clock. Yep.